the microphone was on. So we better get started. Thank you for coming. Numbers are quite small for this session. I can only assume that there must be some really other interesting session going on at the same time. I didn't check to see who we were up against, so I'll have to check that tonight and see who drew the numbers. So I'm Ben Armstrong, Program Manager on the Hyper-V team. Today I'm going to be presenting with Jose Barreto, File Server and Clustering PM, and Simon Perryman, where are you based these days?
I'm still in Redmond.
You're still in Redmond, so you're a technical evangelist.
That's right.
But you're based in Redmond. I thought you'd moved around.
No, not yet.
Okay. So Simon's one of our technical evangelists. And today we're going to be talking about upgrading your private cloud. And this is actually quite a complicated topic to go into. And I do want to be really clear starting this out, and I do want to be completely transparent and honest with you. I would love to be able to get up here and to say, hey, upgrading your private cloud is easy. We're going to release 2012 R2 and you'll deploy it and it'll just work wonderfully. That is not true. We have done a lot of work to make it easier to deploy 2012 R2. We are focusing a lot on the scenario and on enabling people to move to new platforms more easily, but there is still a lot of complexity here. So we have a lot of content to cover today so that you can know everything you need to be aware of. That said, we have more content than we can actually cover. So before I get started, I want to step you through some assumptions and some conditions that we're making for this presentation. So first assumption I have is you want to upgrade your private cloud infrastructure. We are not here today to try and sell you on the value of Server 2012, 2012 R2. I am hoping that you are here because you are already sold on that value. So we're not going to be doing any marketing stuff today talking about how cool this is. We're going to be going through the nuts and bolts of what you need to know. The next thing that we're assuming that it is really important to you that the people who use your private cloud don't notice that it's being upgraded. Something that we have found, whether we're talking to hosters or enterprises, whatever scenario, the people who operate the private cloud infrastructure are completely separate from the people who actually use it. Whether that's an organizational separation or whether it's completely different companies and businesses. And any time that you have to try and coordinate something across these two groups, you just involved a lot of paperwork. And by the way, let's get a show of hands here. Who here likes paperwork? We have 3 people who like paperwork. Fantastic. I'm sure that you are highly employable in today's market. You're going to hear a theme as I go through these assumptions. There's a lot of things that we've heard around upgrade, which actually boils down not to technology, but to paperwork. So you don't want to do the paperwork of having to alert people, inform people, and coordinate the upgrade process. You don't want to have to buy new hardware to upgrade. Why? Because this is a lot of paperwork. Most people I talk to will tell me if they have to deploy a new server platform, that's going to take them today 6 to 9 to 12 months. And a large chunk of that is doing the business case and the paperwork for justifying buying the new hardware to deploy the new operating system. I talk to those same people and I say, well, do you have to do any of that paperwork when you deploy a server spec? No, because I don't need new hardware. So buying new hardware will really slow down the process. Next assumption. Just because you're upgrading your software does not mean you get a free pass on your SLAs. You have users, they have expectations. Similarly, it does not mean that you get a free pass on high availability. People expect that their workloads have the same level of protection. Another assumption that we're making is that guest operating system upgrades are handled completely separately to your virtualization infrastructure. different cadence, highly likely different people. So we're not going to be talking about guest operating system upgrade today. We're going to be talking about upgrading your private cloud infrastructure. So with that in mind, what's the scenario we're going to be looking at? So the primary focus that I'm going to be talking about today is you have 2012 in place, and you're looking at how are you going to upgrade to 2012 R2 when it comes out. We're also going to be talking about if you have 2008 R2 and you want to go to 2012 R2, what is that going to look like? Now, a quick show of hands here. How many people have 2012 deployed in their environment? Let me just make a comment, because I did the What's New in Hyper-V session. TechEd Europe, a lot more people have 2012 deployed than TechEd US, so I'm proud of you guys. I asked the same question at TechEd US, and I think about a third of the hands went up. While we're going to be discussing how do you upgrade from 2012 to 2012 R2, you can actually interpret the information here in a different way. You can interpret it in how should you design a private cloud to be upgradable. Now, most people in most businesses, when they're doing a server deployment, will go through all the paperwork. They will go through buying the hardware. They will go through that pain. And let me tell you, if when you are doing your next deployment, you do not account for upgrade, then you're a fool. Because there will be a point in time when you need to upgrade that. And if you account for it in your initial deployment, then you will be able to upgrade without doing the extra paperwork. But if you don't account for it, you may need to look at, actually, we do need some more hardware for this. So you can look at this in two ways. We're going to be talking about, okay, you've got a deployment, how do you upgrade it? But in a lot of ways, we're also saying, how should you build a private cloud so that it is upgradable? And a note here, there are scale requirements for this. This is actually something that we've spent a lot of time talking about. If you go through all of our assumptions that we listed before, I don't want people using my private cloud to notice that an upgrade is happening. I want to maintain my SLAs. I want to so on. There are scale requirements. If you come to me and say, I have a 2-node Hyper-V cluster, and I want to try and upgrade it with zero downtime and no effect on availability and no effect on SLAs, no, that's not possible. You're going to have to give up on one of those. Once you get to a certain scale point, then we have options. So when we're looking at this deployment, some assumptions that we're making about your deployment. First one, that you're going to have System Center managing your environment. Now, I know that that's not true for everyone. Frankly, I believe it should be true for everyone. If you don't have System Center managing your environment, you can still do this upgrade. There's going to be some more work for you. You're going to have to do some scripting and some manual work. The next assumption that we're making is that you are using Hyper-V clusters for your compute resource. I have had people come to me and ask, how can I orchestrate upgrade with zero downtime and zero SLA effect, SLA impact? Oh, by the way, my Hyper-V servers aren't clustered. Ooh, that's going to be tough. The final thing that we're assuming is that you're using Windows file server clusters for your storage. So here's the deployment. And I actually get teased by the guys back at Redmond because I am Ben Armstrong, the Hyper-V PM, and Jose here is the file server and cluster team PM. And every time I get on stage, I talk about the importance of using SMB, which is Jose's technology. I strongly believe that anyone who is looking at doing a private cloud deployment with Hyper-V today should be using a scale-out file server for their storage. Frankly, I would love you to be using storage spaces on the back end, but hey, if you have a SAN, if you have fiber channel, so on, great, continue to use that, but don't have Hyper-V talk to it directly. Have Hyper-V go through a scale-out file server. There are actually a huge number of benefits to doing that. You will see higher performance. You will see higher resiliency to network glitches and storage outages. And you'll find that in scenarios like upgrade, you now have a lot more flexibility and a lot more options available to you. So while we are here today to talk about upgrade, honestly, if you come up to me tonight at Ask the Experts and you say, Ben, the only thing I took away from this session is that I'm going to go back to my office and I'm going to look at getting a scale-out file server in my private cloud deployment, I will be a happy man, because I believe that's the right decision for you to be looking at. So with that in mind, where do we start? Well, the first thing you need to do in this deployment is upgrade the management software. So upgrade System Center. The reason for this is there are a couple of reasons. The first one, it can be used to orchestrate the rest of your upgrade process. So with System Center 2012 R2, we have committed to releasing it at the same time as Windows Server 2012 R2. And before anyone asks me, I have been told by PR that I am only allowed to say that they are releasing this year. So do not come up and try and ask me, so Ben, when's it coming out? Because the answer is sometime this year. But we have committed to having these releases available at the same time, and System Center 2012 R2 will manage both 2012 R2 and 2012. So it is great to be able to use this management infrastructure to then orchestrate your upgrade. I skipped ahead too soon. The other reason why you want to do this is there are a number of steps through the upgrade process where you are going to be shuffling things around. You are going to be changing network names of different computers. If you leave System Center last to the upgrade, you're then going to have some legwork going through and trying to inform all the System Center components about the changes that you made. Whereas if you use System Center to orchestrate your upgrade, then System Center is aware of what's happening, and you don't have to worry about any false alarms or any confusion in the deployment. So the next thing to look at, thinking about upgrading your management infrastructure, or upgrading System Center. The first thing here to ask yourself is, how critical is each component? You know, different people have different weights that they place on criticality of components. And this is going to affect how you prioritize upgrading these components and how you approach upgrading these components. For instance, a common example that I've seen is a customer may say, you know, in my environment, I have an SLA that I am going to maintain at least a daily backup of your virtual machines. That's my SLA agreement. Well, great. That means that, hey, if it takes 3 hours to shut down your DPM server, do an offline upgrade, and start it up and get it hooked up, fine. A tenant's not going to notice that you've done that. You're still meeting your SLAs. So you need to go through and you need to understand, what are the SLAs I have in place? How do they affect this? Two specific things to call out here. The first one is, we have this document today, the upgrade sequencing order document. It's currently written for System Center 2012 SP1. We will be updating it for System Center 2012 R2 when it releases. This is a really important document to read, because if you have multiple components of System Center in your environment, this steps you through kind of the dependency tree of, hey, you want to upgrade this component first and then that component. The final note to make on this slide, this is actually kind of obvious when you think about it, but if we don't call it out, a lot of people forget and get tripped up by this, is before you start upgrading your System Center deployment, go into System Center Operations Manager and tell it to stop monitoring the servers you're about to upgrade. We have had a number of people go through an upgrade cycle and get to the end only to realize that they had an inbox full of email alerts from their operations manager going like, oh my God, someone's doing crazy stuff to your infrastructure. Go in, turn off the alerts, like inform operations manager ahead of time, I am about to do a significant operation, and then reestablish the alerts when the process is complete. So the one specific component that I'm going to drill in on here is System Center Virtual Machine Manager. This is what you're using to manage your compute resources, manage Hyper-V, and manage your fabric. It is also what you're going to use for a lot of the orchestration of upgrading Hyper-V. So the easiest way to upgrade System Center Virtual Machine Manager. Well, the first thing is, and this is getting back to my statement of you need to be thinking about upgrade when you are doing deployment. Now, unfortunately, if you only think about upgrade the day you want to upgrade, you are going to find that there are cases where you're going to have some tough decisions to make. So if you're thinking about upgrade when you're doing your initial deployment, a great thing to do with System Center Virtual Machine Manager is make sure you put the database on a different server, different virtual machine. Because that actually gives you a lot of flexibility in System Center. Because if the database is on the same virtual machine or physical computer as System Center Virtual Machine Manager, then the upgrade can take a while. If you have the database on a separate server, what the recommended process is going to be is that you basically shut down your System Center Virtual Machine Manager Service Pack 1 installation, bring up a new System Center Virtual Machine Manager 2012 R2 installation, point it to your existing database that was being used by System Virtual Machine Manager 2012 SB1. We will import all that data. We will understand all the servers in your environment, and we will bring that up straight away with no extra steps required from you. So that is the ideal approach, only possible if you have your database on a separate server. So you've gone through, you've upgraded System Center Virtual Machine Manager, you've upgraded your other System Center components in an appropriate order. What do you do next? Well, let me tell you, I have this slide here specifically because of an argument between me and one of the guys on my team named Taylor Brown. And he and I have a big disagreement about what you do next. As far as I'm concerned, after you've upgraded System Center, the next step to do is to upgrade your compute nodes and to upgrade Hyper-V. As far as Taylor is concerned, the next thing to do is to upgrade your storage. Now, I let Taylor win this argument, so we will talk about storage momentarily. But in letting him win it, my one stipulation was I said, I want to put the what next slide there, and I do want to highlight we are stepping through System Center, storage, then Hyper-V. Once you've got System Center upgraded, the order doesn't matter. You can do it in any order. In fact, we are fully supporting if you want to not upgrade the whole stack. Fine. I have no doubt that we're going to have some customers who upgrade their storage and don't upgrade Hyper-V. We will have some customers who upgrade Hyper-V and don't upgrade their storage. These are both supported configurations. You can even upgrade both at the same time if you're particularly reckless. So with that in mind, I'm going to hand over to Jose, who is going to step through upgrading storage while he is upgrading Windows on his Surface.
Yeah, I'm going to the 8.1 preview over here, and I'm eagerly awaiting. It says that it's getting ready, so that's good. Awesome. So let's talk a little bit about upgrading storage. The notion here is we're trying to help you get through the process of going from 2012 to 2012 R2 with the minimal amount of disruption. And we have several tools in our tool chest to go solve that problem. One of them is brought to you by the Hyper-V team, and it's called storage migration. Storage migration allows you to move data between different storage solutions without Hyper-V downtime. And this has been in place there with Hyper-V in 2012. You can do that between 2012 and 2012 machines. If you're essentially, going from local storage to file server storage, or if you're going from file server to a SAN, or SAN to the file server, and you can do that without disruption. That's very helpful. And it essentially is technology that mirrors the storage from one point to the other, copies while the workload is running, and at some point when the storage is equal and the same, you can actually let go of the source and start using the destination. That's an awesome way to do migration. Another thing that we are we'll be talking about is the copy cluster roles wizard. And the notion there is if you are using cluster resources in general, and Simon is going to elaborate a little bit more on that, you can actually copy the resources between clusters to facilitate the move of resources and to facilitate the configuration. Another thing that we have the ability to do is with certain, with particular care, you can actually do an upgrade in place. Of course, for cluster resources, we want to do that by splitting the cluster, moving resources, and then doing the upgrade of one side, and then bringing it over. And we're going to talk more about that. And last but not least, PowerShell is your friend, right? When you're doing many of these operations, you will find out that it's very easy to make a mistake. And if you're trying to do this interactively, it will be a problem. You mistype something, and then you're in a world of hurt. So I would highly recommend that whenever you're thinking about this process, that you really try it out in a test environment, capture the PowerShell required to do that, and when you're going to do it for real in your production environment, you minimize possibility of error by just essentially running a script that you carefully tested in your test environment, okay? So let's talk a little bit about 4 different ways that you could go about making this move from 2012 to 2012 R2. Okay. There are some options there. You'll see this table. There's a column that says no downtime, and there's a column that says limited downtime. Then you have different roles. One is extra hardware, and the other one is just a little bit more hardware, right? In essence, in order to make this process, you could choose to buy extra hardware, enough hardware to actually have side-by-side infrastructures, and that would make your process much easier. However, one of the more challenging pieces here is trying to do this with fewer resources and make your transition not cost you twice as much in terms of storage. The sequence that I'm going to go through is kind of walking from I have a lot of extra hardware all the way down to I have almost no extra hardware. Let's see how it goes. First option, migrate the storage. That option is a common one when you're, for instance, moving between an old version of a SAN to a new version of a SAN. So you have a lease that's about to expire. Someone hauls in a new storage, and you basically can live migrate between the two systems, right? The great piece about this is that you have absolutely no downtime because you're doing live storage migration or just storage migration between the two environments. So Hyper-V stays put and copies the source to the destination, and then when you're done, everything is on the destination. From a downtime perspective, this is great. Now, there are 2 things that really might make this impossible in many situations. One is you need to have as much storage, or at least as much storage as you have today in order to make that move. For some people, that's not a viable option. In other cases, that's doable. Another thing that's important, you are essentially moving the entire data set that you have over your network. That depending on how fast your network is and how much data you have, that could mean hours, days, weeks, maybe. Okay? So you have to look at this and do some planning. For some people, though, migrating the storage is really an option. I have a screenshot here of the cluster tool that's actually very flexible, that you would essentially look at your virtual machines and you would effectively drag and drop them to a new location, and you can do that very, very easily. And obviously, we can also do this through PowerShell. All right. So this is the diagram that describes this. So what you see there is that I have enough storage and enough compute here on the file side to go and perform this side-by-side move. So obviously I'm not showing the Hyper-V layer here. I'm just showing that you have your old cluster with your old storage. You set up a new cluster with your new storage, and you live migrate between the two. After you're done, you retire the old one. Okay. Problem there, everything moves over the network, and you need lots of new hardware. The other piece that you could do is you could use the copy cluster roles. So when you're using this option, one thing that you see is that you get some new hardware for your file server cluster itself, but the storage that you're attaching to that file server cluster, you essentially will move between the two sides. So let's say you have a JBOD full of disks that are connected to your existing infrastructure. You set up a new file server cluster that you wire to the same set of JBODs, and then you essentially make a copy of the cluster resource, and you stop using it from this side, you start using it from the other side. And you can, with this, reduce the amount of extra hardware that you will need. Effectively, you can do this with, let's say you have a 2-node cluster right now. If you buy 2 more compute nodes, you can create a file server cluster, and then you essentially, after you're done, you actually can retire those 2 old nodes and maybe repurpose them for something else. Now, there is one point to be made here. We will have some downtime. Why? Because the copy cluster role will bring the resource information from one side to the other, but at some point, you need to actually offline the resources on one side, and at that point, everything stops working, and then you have to online the resources on the other side, and then it all comes back. Although it's a limited downtime, it is downtime. So you can only take this path if you are willing to, let's say you have a couple of hours to say, okay, there's a maintenance window, we're going to do this, and you have to do that. It's probably going to take less, probably going to be just a few minutes, but I mean, if you're taking downtime, people will notice, you have to let them know. You will effectively have to stop your environment to make this kind of migration, okay? So let's take a look at how you would do this. So in this case, instead of having storage on this side, I just set up a new cluster that has just the new file servers that I put in place. So I had the 2 nodes here. I bought 2 new nodes, set up the cluster. Okay? Next step is I'm actually going to move that storage between the 2 clusters. Okay? We have tools in the copy cluster role wizard to facilitate that, so that you don't actually have to recreate the resources on the other side. They actually get copied over. Simon's going to show you some of this later. But you do have to have some limited downtime. Okay? Now, what is the advantage here? You do not need additional storage. You do not need to copy the data over the network. The data actually stays put in the disks, and you effectively just reconnect to the other side and bring that back on. Okay? Now, Jose, I have absolutely no way that I can invest in additional hardware. Okay? I must just get my 2-node file server cluster and upgrade without additional hardware. Is it possible? Well, yes. But you're incurring some risks here. The risk is, if you have a 2-node cluster, you can actually fail one of the nodes. That's the whole reason why you have 2 nodes, is if one fails, the other one will hold the fort, right? So you could essentially take that guy out of the cluster, create a single node new cluster, and then do the process that I described, and then reestablish that. And that's what I call here an upgrade in place. Now, there are two things that are going to be different here. One is you have to have downtime compared to the first one. And the second one is for some time, you will lose your high availability. Why are you doing that? You're operating on a single node in a cluster, so you're not really fault tolerant. Let's take a look at exactly how this happens. So here's your existing cluster. You have no new hardware. First step is you evict one of the nodes of your cluster. At that moment, you are degraded, okay? Now, you go and wipe out that node, and you set up a new Windows Server 2012 R2 cluster. Okay, that will take you some time. That's fine. The workload is happily running on the other side. Okay? And then you can go and perform the move. Again, as I mentioned in the second case, that move involves using the copy cluster role, right? And it does take downtime. Now, it might be worth explaining that when you're doing the copy cluster role, what you do is you have your resources on this side, you copy the resources. Everything is still online here, and you have an offline copy on this side. Then you go and you say, take this down, then this goes offline, and then you online on the other side. So the process of actually doing that move is fairly quick because we pre-provision that new cluster, single node cluster, and we pre-populate those cluster resources on this side, right? So it's the absolute minimum downtime, but there is downtime. And at that point, you're still degraded. You still only have one node in your cluster until you're done with this. And then last thing you do is after the move is completed and everyone is operating on the other side, you will go ahead and add the second node, you wipe it out, add to the cluster, and you're completing the whole process, okay? Now, I have one more scenario here, which is what I call the move pool scenario. So this is the scenario where you don't have a lot of hardware, but you have a little bit that allows you to plan a move without having to have twice as much storage. So we're counting here on the fact that maybe, just maybe, you have some spare capacity. And you came to a TechEd talk, and they told you about keeping some of this infrastructure, with free resources available, and structure it in a way that you can actually make these kinds of moves. So imagine, if you will, that you have 4, 6 different storage pools in the cluster. And imagine also that that cluster, instead of being a 2-node cluster, is actually a 4-node cluster. So if you have a 4-node cluster on your file server scale-out, you effectively be able to split that in 2 clusters. You can evict 2 nodes, and you still are highly available. And then you can create another one that's still highly available on the other side. And then you can move the resources between those with storage migration. What you get in that case is there is no downtime, and you only need a certain amount of extra hardware. And as Ben was describing, if you do your planning right up front and you keep the number of cluster nodes to a certain, to at least 4, and if you have some spare capacity and multiple pools in your environment, you are actually able to do this. What does it look like? So I start with my 4-node cluster, and in this case, let's say I have 4 pools, okay? So what I'm going to do first is I'm going to go ahead and evict 2 nodes of the cluster. So granted, you're operating with less nodes in your file server cluster. If each of these file server clusters had a 10 gig NIC, your throughput is reduced at that point, but this is not downtime. You're just operating at more pressure on your file servers. If you plan this right, maybe that's enough to keep your workloads running fine. Then you build your new cluster. And because you did this already in the right fashion, there's no messing with cables or infrastructure, because you see, in the previous scenario, when I bring 2 new nodes, I have to actually wire these new nodes to the storage, make sure everything is okay. In this case, because they were already a cluster, then you know that they are properly wired to the storage, that everything is already in place, right? It's a matter of actually evicting the nodes and configuring the new OS. Then what you're going to do is you're going to evacuate that pool 4. What do I mean with evacuate pool? I mean that you will migrate all the VMs that were sitting on pool 4 in pools 1, 2, 3. Of course, if these are pools of equal size, that means you have to have at least 25% of your storage capacity available. If you have all your disks full at that point, there's no way you're going to be able to do that. Okay? But if you do have some spare capacity, you could migrate off that pool. And then you move that empty pool over. Okay? You can even, in that case, just create a new pool, because you can wipe it out. There's no data there. And with that pool in place, you can now move your storage from the old environment to the new environment. And that pool 4 will start getting full. And if you do this right, you actually do it by evacuating pool 3. So you take everything that was in pool 3, migrate over to pool 4. What you have at that end is pool 3 is now available. You move that one until you're all done. And to close, you get your 2 nodes in that cluster, and you migrate to R2. Now, is this the best choice? Well, this is still moving all the data over the network. And in some combination of this, you might actually have to move a VM twice to get it to the right place, right? Because maybe when you're done there, if you saw what I did here, this pool 1, when it comes over, it comes empty, right? As I was moving everything over. So you would have to reshuffle things maybe a little bit. So there's some work to be done there. But at least you don't have to have twice as much hardware to do the storage. And in fact, you could do this all from your keyboard and monitor, because there is no really hardware recabling to make this happen. It's all about reconfiguring the solution, right? So I guess the lesson I would give you here is plan ahead, put some extra capacity in your environment if you have the aspiration of migrating in the future, okay? With less and less downtime acceptable in most situations, you will eventually need to make this move. And if you have at least a few of your VMs that cannot ever go down, you might want to have that extra capacity to make these kinds of moves possible. And keep in mind also that in the real world, not all VMs are created equal, right? So for some VMs, you can do this live process. For some other VMs, you can say, you know what, I'll just do the copy. I'll keep some of the stuff here, and I won't do the live migration. I will actually just shut them down and move them over, and I won't care. So I won't be so careful with these. But for at least some of your environment, it's harder and harder to tell people that there's going to be downtime. Okay? Now, back to compute.
Thank you very much. Yes, don't forget your Surface. It's actually a really good point that Jose just made about considering the requirements for your virtual machine. As we've been working on 2012 R2, I actually had an opportunity to have the upgrade discussion with a large hoster who had deployed 2012, and they were looking at moving to 2012 R2. We stepped them through all of these options and so on. And when they first came to us, they came to us and said, no downtime is acceptable. We have to do this all with zero downtime. And we're like, okay, and we worked with them and we stepped them through the last process that Jose had just mentioned. And when they sat down and they did the math, and they're like, well, okay, that's going to work, but in order to do that, we are going to be doing a storage migration of all of our storage over the network. And when they did the math on their environment, they had a staggering amount of storage. And it worked out for them that if they wanted to do a zero downtime upgrade for all their virtual machines, that they would probably be spending about 6 weeks copying data over the network. So it was quite amusing for me, because after they sat down and they did that paperwork, then, not before, then they turned around and said, you know what? We have 3 tiers of offerings in our environment, and only the gold tier requires zero downtime. The silver and bronze tier, we actually have worded in them that there will be downtime for maintenance, windows, and so on. And so they actually ended up deciding to use 2 of the approaches that Jose mentioned, where for their gold tier, they used the 4th approach, and they were able to upgrade those with zero downtime. But for the silver and bronze tier, they used the copy cluster roles to move it across quickly without having to transfer that data over the network. So now to talk about upgrading compute. So you've got your management environment upgraded, you've got your storage upgraded, now you want to upgrade Hyper-V. What does this look like? Well, the simple thing is, our recommendation is use cross-version live migration. Technology coming in 2012 R2, we now allow you to live migrate a virtual machine from 2012 to 2012 R2. And one of the key things here is this works no matter what your infrastructure. Whether you're using standalone, whether you're using cluster, whether you're upgrading your storage, whether you're not, all forms of live migration. So cross-cluster, cross-version, shared nothing live migration, yep, that works. You can also do cross-version, cross-cluster migration where you leave the storage in place. Also works. So what does this process look like? So I have my Hyper-V cluster. I've got a bunch of virtual machines on there. What I'm going to do is I am going to, most likely, using System Center Virtual Machine Manager, I am going to put 2 of the nodes in my cluster into maintenance mode and move the virtual machines off them. Then, much like what Jose was just talking about with storage, I'm going to evict those, and I'm going to create my new R2 cluster. And a key thing, all the steps that I'm talking through here, these are all doable directly through System Center Virtual Machine Manager. So I can go through System Center Virtual Machine Manager, I can evict the nodes, I can provision a new cluster. Then I can use System Center Virtual Machine Manager to start moving virtual machines across, and once I've moved them across, evict a node, move it across, and just go through the rest of my cluster in that fashion. Now, I am going to do a demo. I'm going to cheat. I've been having VPN problems, so I'm going to show you a very short video of my demo rather than showing it you live. I will give away a secret. Simon is here madly trying to get his VPN issues resolved.
Don't tell them
Shh. And hopefully he will be able to outdo me and do his demo live. But I'm going to just do a short video. If you saw my presentation on what's new in Windows Server 2012 R2 Hyper-V, you will have seen me doing a cross-version live migration there using System Center Virtual Machine Manager. I did want to take a moment to just highlight you can do this with or without System Center Virtual Machine Manager. And this is actually just a short video of me doing a cross-version live migration using the Hyper-V management tools. And the key thing that I want to point out here is if you are familiar with doing live migration in Hyper-V Manager, what you're going to notice is nothing is different. The only difference is I pointed it at a 2012 R2 server. This is something that we did a lot of work to make sure, and there. simple video. So there is no complexity in planning here. This has actually been something I've had a lot of people asking me for, like, Ben, can you step me through the whole detailed process of doing a cross-version live migration? And the whole detailed process is you go to the source computer and then you live migrate to the destination. Or you use a single PowerShell commandlet. So we did a lot of work, so there are no special configurations that you need to do in order to make this work. So you've done your cross-version live migration. The next obvious thing is, but wait, what about the integration services? So it's a new version of Hyper-V. There's a new version of the integration services. Now, what you don't want to do, because it would be kind of silly, is you don't want to go to all the effort of doing an orchestrated cross-version live migration, and then first thing you do after your virtual machines arrive on the other side is install integration services and reboot them straight away. That would be silly. If you did that, why didn't you just shut down the VMs and move them across? So what our recommendation is what you're going to want to do is, and you can actually do this either before or after doing the cross-version live migration, is you are going to want to stage the next version of the integration services so that they will be loaded on the next natural reboot. Whether that is because some other patch was deployed to the guest operating system, or whether it's just when the user of the virtual machine causes a reboot to it for some configuration change that they're making. So this is something that we fully support. And here's the command line for it. You take the integration services deployment that we have. We have it in the ISO file. It's also available just as standalone files if you want to put it on a network share. And rather than just running setup and going through the normal GUI, you run setup, quiet, no restart. And what that will do is it will stage all the components for the integration services there. Next time the virtual machine reboots, we will make sure that they are updated. So what are the alternates here? Because one of the things that I did gloss over, and hopefully some of you thought about this, is there are going to be cases where evicting 2 nodes from your existing cluster is not really an option. Honestly, from what I know from talking to customers, my expectation is evicting 2 nodes from a Hyper-V cluster is reasonable if you have about an 8 to 10 node cluster or higher. I'm fairly confident that if I went and talked to someone who had a 10 node Hyper-V cluster and said, yes, for upgrade, evict 2 nodes, they'd go, yeah, okay. I'm also fairly confident that, actually, I should have a show of hands. Actually, let's skip that. I'll just say, I will tell you, I find this fascinating. The most common cluster size deployment that I hear for Hyper-V is actually a 3 node cluster. That's the one that I hear, so many times when I'm talking to people. I come to these trade shows, and I can tell you, at these trade shows, over half the people who come by the booth and talk to me about clustering come up and start with, I have a 3 node cluster. Now, obviously, if you have a 3 node cluster, evicting 2 nodes from the cluster is a non-starter. So what are the alternates? Well, one alternate is evict 1 node and start your 2012 R2 cluster as a single node cluster. That's going to work at any size point. What it does mean is you have a period where you don't have high availability on the destination. So that is a risk and a trade-off to take. If you're running at a smaller scale size, or if you have larger clusters, but you have them heavily loaded so you can't evict 2 nodes. You could evict 1 node, start with a 1 node cluster. You will have to accept that for the period between when you start live migrating virtual machines onto that cluster and bring across the second node, you don't have high availability. The next one is you could buy new hardware to act as a seed. Maybe you're not comfortable with that. Getting back to all the different customers that I've talked to, if you're someone who has, let's say, you have a 5-node cluster, and it is running at 80% capacity, you can't evict 2 nodes, but you also don't want to go out and buy 5 extra nodes in order to do upgrade. Well, all you actually need to do in that configuration is to buy 1 computer. Because if you buy 1 computer, evict 1 computer from your existing cluster, you can now create a 2-node cluster. And you can do the whole process with availability throughout. The final option is much like José's discussion. There are alternates that may give you advantages but involve downtime. So this is something to consider and to be aware of. So a couple of things that we have talked to people about. In making cross-version live migration work, we actually made cross-version pretty much anything work. So if you've done an in-place upgrade, actually let's see a show of hands. How many people have done an in-place upgrade of Hyper-V before? About a third of the people here. If you've done that before, you know it's a really painful process because we don't support snapshots, we don't support save states, you have to get everything just right. With 2012 to 2012 R2, that's not true. We do support snapshots, we do support save state, it all just works. Wherever your VMs are, fine. It's interesting, we've actually worked with a couple of customers going through this process, and we have had, not many, but we've had a couple of them come back and say, actually we really liked going with the in-place upgrade because it meant that I didn't have to reset up my networking. It meant that I didn't have to reset up all the tweaks that I'd made to the system. So one of the scenarios that we've seen customers doing, just to make this process as easy and foolproof as possible, is if you go back to the original diagram where I talked about evicting 2 nodes, making a new 2-node cluster, what they did was they evicted their 2 2012 servers, and then they did in-place upgrades on those. Because by doing in-place upgrades, they kept all their virtual networking configuration, and they kept all their drive and system configuration, so that they didn't have to re-step through all of that. And then they created the cluster and moved across, and as they brought the nodes across one at a time, what they were actually doing was they were doing in-place upgrades on them. The next thing to be aware of, and this is something else that I've had a customer look at, is we also support cross-version virtual machine import. So where can this become handy? This can become handy if you have just a staggering number of virtual machines that are sitting on a SAN. And if you've sat down and done the math and being like, well, if I live migrate all of those, it's going to take a while. This is where an option is using the copy cluster roles that José talked about and Simon's going to be talking about. What you can actually do, just save state all your virtual machines and basically unplug the SAN from the source, plug it into the destination, relatively quick operation, import and start your virtual machines. All fully compatible, all fully supported. So one final note, and I always hate when I say one final note because whenever I say one final note, there's an extra slide after that I've forgotten. I should never say one final note. But I've said it now, so we'll see if I've forgotten a slide or not. One final note that you should be aware of is when you're upgrading your compute cluster, if you are not using file server storage on the back end, there is an issue with validation. And that is, in order to pass a cluster validation report and do a full validation of your cluster, cluster validation actually takes your storage offline. That's a problem. If you're using storage directly attached to your Hyper-V nodes and you're running CSV on your Hyper-V nodes, you don't want to do that. You don't want to take it offline. So what do you do about validation? The first and obvious thing is you run it, use your storage on file server, and then you don't have this issue. We can do full cluster validation. The second thing is I've actually been talking with the program managers on the clustering team about this. And they're looking into what they can do to get the messaging clearer around this. As far as their interpretation of validation is concerned, is if you had a validation report for a cluster where you had excluded the storage, as long as the problem you were seeing was not specific to storage, they believe that Microsoft support should take that call and support you. Now, I believe that Microsoft support will say, have you run validation? And if you say, well, kind of, they'll say, well, we don't want to talk to you until you've run validation. So that's something that I'm working with the clustering team to see if we can come up with a better story about that. Today, my recommendation, use Windows File Server so that you can get the full validation report on your compute cluster. We'll take questions at the end. So now, I'm going to pass across to Simon. Have you got your demo working?
We're ready.
Fantastic. And Simon is going to talk about what about moving from 2008 R2 to 2012 R2, and also give us some more insight into the copy cluster roles process.
That's right. Thanks, Ben. Hi, everybody. So the reason why I'm up here, I used to be one of those cluster program managers that Ben was talking about. I used to own the migration feature. So if you like the design, I'll take credit for it. If you don't, I'm no longer the owner. You get to blame this other guy called Rob. So let's take a quick tour of the copy cluster role wizards. Now, this was originally called migrate a cluster wizard. And we've had so many different terminology around migration with live migration. Now, we just decided, you know what, let's simplify it. We're just going to rename it. So it's now called the copy cluster role wizards. What this means, though, if you're looking at documentation on TechNet, we haven't updated all of it yet. We're still working on the 2012 R2 documentation. So make sure that you maybe have to look for the migration wizard still as part of this, as part of your deployment. Now, we support 2 levels down level. So what this means is we can copy roles from 2008 R2 to 2012 R2, 2012 to 2012 R2, and we can also copy at the same level, 2012 R2 to 2012 R2. So why would you want to do that? Well, we see some customers doing consolidation. So they have multiple clusters, and they want to kind of merge all of the workloads onto a single cluster. You could do that using this wizard. Now, what we say by copy cluster roles, key thing here is we're just copying the information. We're not migrating it. So that was something else that was a reason for this change. What we mean by that is we're essentially cloning the resource and moving it onto the new cluster. But the old one still stays online, still stays running. This gives you the opportunity to go and test this migration before you do it in the real world. Now, the reason why I wanted to do this is migration, as we've talked about, does involve downtime in many cases. So we wanted to give you this kind of testing capability as well before you kind of had to do it in production and hope that things work. Now, the process, since we're not actually destroying anything on the old cluster, fully reversible. You could try copying it. If things don't work, things don't come online, take them back offline, bring everything back online on your old cluster. So again, nothing destructive. We don't make any changes for you on your old cluster. So a great opportunity to really just test this, make sure that it's going to work as you expect. Now, as we do this, we give you the option to either use new storage, and we have, or continue using the existing storage. Now, depending on the workload, we will actually show you in the UI an ability to remap the different storage, and I'll show you that shortly in the demo. Now, we do make the assumption that you will continue to use the same storage, though. This is the general case. We find that people, aren't often simultaneously upgrading both their hardware, the servers, as well as their back-end storage. It's usually just the hardware. They're just updating that, but they're keeping the same storage. So we have this assumption you're going to continue to use the old storage. Now, if you do use new storage, one limitation of this copy cluster wizard is that it does not actually copy the data for you. Okay? So it copies the cluster configuration information. And this includes the name of the workloads, the different private properties, what disk they're accessing. If it's a virtual machine, it will copy the virtual machine configuration file. If you're using cluster shared volumes, it will remap the cluster shared volumes information. But again, if you're going with new storage, we won't actually copy the data for you. But you can use any other type of file copy solution, robocopy, xcopy, anything like that. Now, quickly walking through this again, we have my 2012 old cluster, have some VMs up and running. I build my 2012 R2 new cluster. We do a copy, but they're still, all my VMs are still online only on the old cluster. Haven't brought them online on the new cluster yet. We have a point where we want to switch everything over, take it offline on the old cluster, bring it online on the new cluster. And again, if something doesn't come online, not a problem. Just leave it on the old cluster, sorry, on the new cluster. Don't worry about it. You can restart it back on the old cluster. Now, with this assumption here, though, you can see that both of our servers, both of our clusters, are sharing the same storage. So essentially, what we've done is we have our storage masked to our cluster masked to shared storage on our old cluster, and then with our new cluster, we point it to that same storage. Bring it online. After we've moved everything over, we could disconnect it from the old cluster, keep it up and running on our new cluster. So what exactly will it copy, this migration wizard? Still using the old name. This copy cluster role wizard. So we could copy all of our Hyper-V virtual machines. And we do some customization as well, allowing you to remap virtual networks. I'll show you that in the demo shortly. We have the ability to copy our scale-out file clusters, CSV disks, storage pools, and then most of the built-in clustered workloads. So this doesn't just support Hyper-V and file, this supports almost all of the roles on the cluster. Now, there are a few exceptions, some things that it does not support. And the reason why, these different workloads have their own migration process. SQL has built-in rolling upgrades that it can use, where it will serially go and upgrade each of the nodes in the SQL cluster. Exchange Server allows you to do a replication mechanism to move information and your databases and mailboxes from your old cluster to your new cluster. Print Spooler no longer runs directly on a failover cluster in Windows Server 2012. Their high availability model for the print spooler has now changed to run just inside a virtual machine while we're monitoring the print spooler servers. So there is no migration path from 2008 and earlier print spooler because it doesn't run directly on the cluster anymore. It's going to run within a virtual machine on the cluster. And we're constantly monitoring the print spooler service. Remote Desktop Connection Broker. They've also moved away from running directly on the failover cluster. They now have different redundancy models to actually provide their own high availability solution. So there's no upgrade path for the Remote Desktop Connection Broker because it's not running directly on the cluster anymore. DFS replication. Well, DFS replication is basically a way to move files, move folders anyway. So you can actually replicate from your old version up to your new version. So that has kind of a built-in migration utility. And there's a few other cluster components. Our VSS shadow copy service, our tasks, cluster-aware updated information, that you do have to do some manual processes to move across. But key thing here is all of the cluster roles, all the cluster workloads have some type of migration path if they're continuing to run on 2012 clusters. Now, one key thing is we wanted to make this informative. Now, we got a lot of success, a lot of popularity with our validation wizard. Gives you the nice report, tells you everything that's happening in the cluster. So we built something similar as part of our copy cluster roles wizard. You will actually get a report before you run the migration saying, we think that these roles can be migrated. This will have additional downtime because you need to fix up additional things. And then once we actually do the migration, you get a post-migration report that confirms everything that happened. It shows you what happened, what resources were updated, what virtual networks were remapped. And this always gets saved in your cluster reports folder, so you'll always have the information when you need to go make this change. So let's actually take a look at this demo here. I'm going to switch over briefly to my demo machine. And so right now, I'm looking at an older cluster. So my old cluster over here is going to be called TechEd Africa. You can see from the UI, it's going to be slightly different from my brand new cluster over here. My 2012 R2 cluster. So for simplicity, I'm going to say I'm migrating from my old cluster to my new cluster. Now, to help you with the display, I'm actually going to go and add my old cluster under management here. This way we can kind of look at both roles on both clusters at the same time. So I get to say connect to cluster. And what it's now going to do is just ensure that I have credentials and I can actually access this old cluster that I'm trying to import. And here we go. We can see that I'm simultaneously managing both clusters now. Now, one of the new enhancements under Failover Cluster Manager GUI is we actually try to make it a little easier with our multi-cluster management. So you can kind of see what's happening on all the nodes. You get a nice view of what's happening across these multiple clusters. So node status, number of roles. And we can see from my new cluster, I currently have 0 roles deployed. So 0 roles. Got my disks, but nothing actually deployed on them. So let's go ahead and take a look at my old cluster. And we can see that I have several virtual machines. I have a clustered DHCP server. And I also have the clustered Hyper-V replica broker. So the Hyper-V replica broker, if you're unfamiliar with it, it's essentially a replication engine for Hyper-V replica that's made highly available on the cluster. Now, one of the changes with Hyper-V replica, running it on a cluster versus on a standalone server, is that on a cluster, there's a single instance as a highly available resource that will actually fail over between nodes. We realize that if you're using Hyper-V replica, it's going to be important to actually make sure that replication always happens. And so we make this replication service highly available. If a node that's running the replication engine crashes, replication broker fails over, comes online. But this is a singleton. You can only have one replication broker on a cluster. For this reason, you could do replication between 2 clusters, standalone host to a cluster, cluster to standalone host, 2 standalone hosts, but you actually cannot replicate within a single cluster. There's only one Hyper-V replica broker, and you cannot replicate between the nodes within one cluster. So we're going to take a look at how we migrate this resource, talk through a traditional cluster migration with DHCP, and finally show you the Hyper-V migration. So to actually perform this migration, I got to go to my new cluster, because we always point back to the old one. And I'm going to go to More Actions and say, Copy Cluster Roles. Now what this is going to do is just ask me, what's the name of your old cluster? So we're going to add our TechEd Africa cluster. It's going to connect to it, make sure that I have permission to actually access the nodes. Now it actually starts to gather and inventory all the different workloads. Next, it's going to go and start to build this pre-migration report. And once it knows what the different workloads are, figure out what of these different components can be migrated, what will require some additional extra steps. Now first, let's go ahead and take a look at our DHCP. I'm going to click Next. Actually, you know what? I've been bad. I did not view report. Always got to review the report here, because it's going to tell me some useful information. It's going to tell me that with my DHCP server, I'm going to be able to migrate it, but there's going to be some additional manual steps required after I do this. So as I'm planning this migration and I think, hey, I may have some downtime, it's good for me to really understand that I need to be particularly careful. I need to plan that I may have some extended downtime. Now we do try to be prescriptive and tell you exactly what happens here. Now it's also going to tell me that we will have to change some driver letters. So this will be kind of the extended downtime with my DHCP server. Now as I go take a look at my other roles, I can migrate my replication broker, no problem. Can't migrate task scheduler tasks. And then I can migrate all of my virtual machines. So this kind of helps me plan what I want to do. Now for my DHCP server, go take a look, click Next, and here's where it will ask me if I can actually remap something. Now, regardless of this being DHCP, you're going to see the same process for all the different clustered workloads that are not virtual machines. Okay, so you migrate file server, DTC, MSMQ, WinServer, iSCSI target, ISNS server. All of these other built-in cluster workloads are going to follow the same process, giving me the ability to use the same storage or select new storage. Now, by default, we're always going to be using the same storage. But for fun, let's go pick something else. What this will then do is give me the list of available disks on my new cluster. And any of these disks should work for the sake of the demo. So we're going to say in the old cluster it was disk 1, in the new cluster it is disk 5. Now one of the nice things about the migration wizard, we go and we automatically update the resource properties. So DHCP in its cluster property originally said cluster disk 1. As we do the migration, we've now updated the disk number, so when it comes on the new cluster, it will say cluster disk 5. This way we're trying to speed it up, reduce those additional configuration steps for you. Click Next. It's going to confirm all the information. Click Next again. And just takes a few seconds to copy it over. So I take a look at my post-migration report. It's going to tell me, hey, everything's moved over. But it also tells me, hey, there's some additional steps here. You have used new storage, but you haven't copied the data. Now remember, let's say with the DHCP, our data is the actual DHCP mapping of the IP addresses on our old disk. If we want that information available, we would then have to manually copy that over to my new disk, then bring the disk online. So remember, we're using this new storage, so we have this additional step of copying the data that we do not do for you. So I'll click Finish, and if I go over to my new cluster now, I can see this is available. Now let's go ahead again and actually copy our Hyper-V replica. Because I'm then going to show you, actually, let's do it with the DHCP. I'm going to show you one of the most common misconfigurations we have. Now, if I try to bring this disk online here, this resource online, it's going to fail. Now, the reason why it's going to fail here is because I still have my old one running on the old cluster. Always got to remember, offline the old one before I bring the new one on. They're using the same IP addresses, they're using the same cluster network name, and so you can't have two servers with that same IP address, that same network name. It'll have a conflict. So this will fail as we expect. Now next, let's go ahead and do this proper migration with our virtual machines. I'm going to go back to our cluster migration wizard, copy cluster roles, and in this case, point back to my old cluster, TechEd Africa. It's going to go through the same process of connecting, giving me the inventory. Now in this case, I'm using cluster shared volumes. We migrate on the CSV disk level, not on the virtual machine level. Now this is important because this means if you have 4 virtual machines on a single CSV disk, all 4 of those virtual machines are going to move over at the same time because we move based on the disk. So it's basically maps to your CSV disk. And in a second, we'll actually show you how we do this in the UI to make sure that it's intuitive. So essentially what we're going to see here, as I go and expand my CSV disks, I see I have 2 virtual machines on this one, 2 virtual machines on this one. If I select either of my VMs or deselect either of my VMs, it does that bulk selection because, again, we're bounding this by our CSV disk. So let's go ahead and select these, and we can even select our Hyper-V replica broker. I would here, go and view my report again. We've already taken a look at it, so we can skip this step. Now, next thing it asks is for us to remap our virtual networks. One challenge that we saw a lot of customers have is forget to update the names of their network. On their old cluster, all of the VMs were using network old. On our new cluster, the virtual networks, network new. When we move these VMs over, when we bring them online, we want to make sure that they're already using the right virtual network name. So we'll go and automatically update that in the virtual machine configuration file. So you don't have to worry about it. Should be able to bring our virtual machines online as soon as possible. So in this case, it gives us the option of mapping our networks. So old network to new network. And I will pick this one. Click Next. Confirm the information. And you're going to see everything get copied across. Now let's take a look at it in 1 second after we copy this over, how things change on our new one. Now, some other tips and tricks here. When you're looking at copying the storage, one thing you want to think about is trying to use the most efficient storage copy mechanism as possible. So if you have your old storage, your new storage, don't go use the Windows shell copy and paste, drag and drop between these 2 different ones. We really recommend if you have a storage vendor, EMC, Dell, one of the major ones, use their preferred copy mechanism. Even better, if you have ODX, offloaded data transfer, that allows you to do direct copy between 2 storage arrays, do that. It's going to be much faster to really try to minimize that amount of downtime as you're copying between your 2 clusters. I can click View Report once again. I get some pretty good information saying that everything looks pretty successful. And I get the details of what's happened here. So I can see everything's been changed. We've created all the dependencies, all the new checkpoints. And this will, again, be stored in your cluster reports folder. So you always have that inventory. I'm going to click Finish. I could go over to my new cluster, and I can see all of my resources have been moved over. Now remember, the DHCP failed. We did that on purpose because we had that conflict with the IP addresses and the network names. But you can see with everything else, all of these resources are currently offline. I go take a look at my disks. And I can see that we've now added 2 new CSV disks. So those were the CSV disks from my old cluster, move them over to my new cluster. Now what we would do here, this takes a couple seconds, a few minutes, so I'm going to skip the details of this, but what we're going to do here is basically go to our old cluster. We're going to shut down the VMs that we're not going to use, shut down the services we're not going to use, stop roll. This is when we start to have downtime, okay? So from this point on, downtime. We're going to go to our storage on our old cluster. We're going to unmask it. So we go take off CSV disk 2, CSV disk 3. Because we don't want 2 clusters trying to access CSV disks at the same time. Only one cluster can own these CSV disks. Again, we still have downtime. Now this would be the point, if I was doing a copy of the data, I would copy it from my old over to my new. In this case, we're using the same storage. We can skip that step. Now what we do, go back to our new cluster. We can bring our disks back online. Go back to our VMs, bring all of our VMs back online, and our other resources, and this is when we'll be able to do our switchover, and you will have a cluster migration complete. Now I'll just start this process, but I am out of time here, so with that, we'll start the process, and we will bring Ben back up to cover our summary and open it up for questions.
All right.
So, thank you, everyone. The key takeaway that I really want people to get from this session is doing a private cloud upgrade is possible, but it requires planning. So please, as you're looking at this in your environment, be aware of the tools and options that are available. Plan your upgrade carefully and be aware of the trade-offs that you need to make. How much time are you going to invest in this versus how important is maintaining availability, maintaining the SLAs, maintaining uptime. And really, moving forward, and let me deliver the PR-approved line. As Microsoft continues to, deliver software at the pace that the industry and our customers demand.
Sounds good. Keep going. I'm in a marketing role now, so I have to approve.
It is important that as you are designing new deployments, you are considering what your upgrade strategy is going to be and that you have the right infrastructure in place for that. So at this stage, I'd like to thank you all for being here. I will put out a plea. Please make sure you do your evaluations. Little known fact that not many of the attendees know is that we only get to count the eval score if we have a minimum of 10 evaluations. So please make sure you do your evaluations. If only 9 people do it, they don't count that feedback. Also, another thing that not many people know, we get to see all the detailed feedback. So please write in any feedback, any thoughts. With that said, I'd like to open for questions. So the question is, with the comment about cluster validation requiring disk downtime, he was saying that his being only offlining one disk and doing the validation on that. Yes, that is a fully supported configuration, and if you have built your cluster so that you have a disk that you can take offline for the purposes of validation.
But that assumes that you are using the method by which you evacuate a pool.
No, I believe what he's saying is he actually has a completely unused disk.
Yeah, if you have it, then you're fine. And if you're moving,
very,
by
very
pool,
clever.
as we
So
were
he
describing,
basically he's creating a 15 megabyte LUN solely for the purpose of being able to always pass validation. Yes.
yeah.
Fully
And
supported,
if you're doing
good
the
idea.
method by which you actually have a set of disks that you evacuate, you can actually run validation on that set and then do your migration. And that is a fine way to do it. The only thing is you'd have to do it multiple times to say, okay, I validated this pool, then this pool, then this pool, because they are only empty for a short amount of the whole process of moving. Right?
Now, I'll also add to that, another way that you can get around, at least with virtual machines, and validate a real disk that a real VM is running on, go do storage live migration, go put that VM somewhere else, do the test in the cluster. Once it's tested, go bring it back. And so then you'll have no downtime with the validation, and you can test the real disk in production too.
That's it. I like his idea. So the question is, can I use my backup applications to help me do the in-place upgrade? Absolutely. As I said, when we did the work for cross-version live migration, we enabled cross-version everything. And cross-version backup restore fully supported.
That includes DPM as well. You can use DPM with full live migration support.
Yeah, even net, and anyone who backs up Hyper-V, it's supported.
Yeah, sure, I can tell you that. So, so we actually do update the CSV namespace as part of the migration. So let's say you have CSV disk 1, volume 2 on the old cluster, and on your new cluster you already have volume 1, volume 2. We'll then make it volume 3, volume 4, we will remap it, and we will update the VM's configuration file so that everything points the same. One challenge you have, though, if we do that, you want to make sure that the application, so with virtual machines, if we will update the CSV disk. If you're migrating other applications and you have disk 1, disk 2, it becomes disk 3, disk 4, you may have to manually go and update the resource and say, hey, resource, DHCP server, you're no longer using this, you're using this.
Yeah, but with virtual machines, it's all magically handled.
Yep.
We didn't restate the question. So the question was when you're copying virtual machines with the copy cluster role, how do you handle the potential for namespace collision between CSV volumes? And the answer is we do.
We will do that. We will increment them, and you don't have to worry about it, basically.
Any other questions?
Cross-cluster live migration. Will it be possible to orchestrate that from VMM R2?
So the question is, will it be possible to orchestrate cross-cluster live migration from VMM R2? Absolutely. I demonstrated it earlier this week.
Because, normally if you do it by hand, you have to first take the VM out of the cluster.
Correct. And VMM actually handles all of that for you. It's very nice. You can actually you can do cross-cluster live migration with VMM 2012 SP1. And it orchestrates removing from the source cluster, adding to the destination, and all of those details.
Yeah, I would highlight a few things. One of the interesting things is the support for Hyper-V over SMB sometimes comes to the rescue of even old block storage solutions, right? So many of these migration options that we have are under the covers using SMB to do some of the data movement for you. And the beauty of these more flexible solutions with file server storage is that we can actually easily have two Hyper-V clusters that point to the same storage on a regular basis if it's file-based storage. When you're doing this with block storage, you're actually dancing over very, very dangerous ground when you expose multiple LUNs to different clusters and you have the risk of onlining things here and there. So when Simon is doing that, I'm always a little tense when he exposes block storage to multiple nodes of different clusters, because if you, all it takes is one wrong onlining to bring the whole thing. So you have to be extremely careful, right? With file storage, you essentially can actually live on an environment that you have 10 Hyper-V clusters here, 10 Hyper-V nodes here on a cluster, 10 Hyper-V nodes there, and they all use the same file server cluster. And it's all handled through ACLing, and it's a regular day in the office, right? So that's part of it. And some of these cross-cluster migrations actually involve moving with SMB in the back.
Yep. So I will wrap up now. I believe we're actually supposed to be in Ask the Experts right now.
Oh, yeah, you're right.
So if you have further questions, feel free to hunt us down. And thank you all for your time.
Thank you.
Thank you.